Welcome to another video about CMake and embedded software. I will be porting a Makefile project to CMake. This one is much easier and should be non-intimidating, so if you still use Make, or even if you're stuck in your IDE and you don't know how your source code turns into binaries, this is for you. Why this video? I've been using a development kit that I found on the internet. The included software is fine, but I wanted to port the Makefile to CMake. Doing this was very quick and easy, so I think it's a good example for discussion. My goal here is to show you that it's easy to switch to CMake and take control of your firmware build process, no matter how deep you are into a legacy project. This video does have some intro discussion, so skip ahead if you want to see the work get done. I'm basically just going to introduce the kit, show you what it consists of, and show the process of using a reference project from the internet, and how I decided that it was a good reference. Let's introduce the kit here. I'm working on some audio processing projects, and I wanted a dev kit with a codec, line in and line out. I couldn't find anything by ST or another vendor, so I started Googling around and found Eric's project here. It really is an excellent reference project. Could not ask for more. So, first thing you see is the picture on the site, and immediately it looks acceptable. Got the F4 micro, the Wolfson codec, line in, line out, LEDs, FTDI and SWD headers, I/O expansion header, simple power supply, and mounting holes. I don't need the USB or the micro SD, but by inspection I can just ignore these and not populate the connectors. Everything on this board is completely obvious, which is good, compared to some other vendor dev kits which are not so good. I don't even have to look at the schematic, it is so clear. By looking at the picture of this board, I knew I could build this by hand. Literally the only thing I would change is to add test points and make the footprint pads a little longer, because the two ICs were a little hard to solder by hand. But that's a statement to how well this matched what I wanted. Then we get to this design resources. Schematic, BOM, Gerbers, 2 firmware projects. Absolutely amazing. So now the part that this video is about, I looked at the source code. To me, the biggest wheel which I did not want to reinvent was the codec driver. So I was interested in the general software quality, is it crap or not, and then does it actually work if I build it and flash it. Fortunately, both were more than acceptable in comparison to some other references I've seen. Okay, now let's take a look at this firmware project. So I've downloaded the zip here. Now I'll unzip it. So this is all the files. Very good. I like that the ST library files are individually placed here, as opposed to having the entire library in the project, or having the entire library somewhere else and pointing to it. It gives me confidence that this is a small, simple reference project. Why would it not work? So what's in here? Anything having STM32 in the name is ST, anything having core is ARM, and everything else is project specific. So this is completely self-explanatory. ADC for the potentiometers, codec and I2S for the codec, and the application will consist of main and audio delay. So far this is good. And now the ultimate test. Does it compile and run on the target? I don't even care what the code looks like yet. If it doesn't compile or run, there's a large chance I'll ditch it. So, yes, it builds. Got object files and the main.elf here. 32-bit, ARM, and size looks reasonable. Alright, so now I'm confident I can go ahead and order some hardware and get this thing going. So here's the board that I built. I have it connected to a ST-Link 3, and the board is powered by the USB. I've also added these 1/8 inch to 1/4 inch adapters so I can play guitar. So first I'll copy this ELF file into my temp directory for easy access. And then I'll go to my OpenOCD install and try to connect to the target. So I'm going to telnet into my OpenOCD. Now I'm going to list the flash banks. Now I'm going to try to erase that bank 0. Flash erase sector 0, starting at 0, going to last. Okay, now it's erased. And so I get this not halted thing. That's because ST-Link is not in control of the reset. So what I'm actually going to do is modify this file change the reset config to none, so it's not going to try to use the reset line. And then I'm going to say open OCD into this. And now it's reset and halted properly, and we can see the PC is just not moving. Good starting point. Okay, so now I can just go into GDB, load up this ELF file, and we're going to connect to our remote GDB server. Remote 3333, and just do a little test that we're there. Monitor, reset, halt. Okay, and now we can just say load, and it transferred. Great. And we'll reset and exit. So just in case your ears could not tell, that was indeed a demonstration of the development kit running the provided firmware project. The firmware does a delay plus feedback effect. It sounds fine to my ears. I'd need to get some test equipment set up to see the frequency response in the noise floor. So that's it. This introduction was way longer than expected, so I'm splitting this into 2 videos. The next video is only about doing the conversion from Makefile to CMake. But I hope this was a good introduction to show you how to evaluate and get up and running with random stuff you find on the internet. Again, shout out to Eric. Great work. 8 years later, it's still good. Thanks for watching.